Good afternoon, ladies and gentlemen. Today we're going to be looking at spheres, finding the volumes of spheres. Volume of spheres I'm separating out from pyramids, prisms, and cylinders and cones just because the volume equations are quite a bit different. They don't rely on one another like the other ones did. So, I'm sorry if you missed today's class. Ask me about my pizza joke sometime. It's a pretty hilarious joke. Anyways, here we go. Parts of a sphere. There are several pieces of a sphere. If you've ever looked at a globe, you know that the top and bottom of a globe are both called the hemisphere, the northern and southern hemisphere. Any sphere is going to have a hemisphere. You can cut a basketball in half and it would have a hemisphere, literally meaning half of a sphere. Around it, we have what's called a great circle. A great circle, which, if you think about the Earth, think about what great circle the Earth has. Yeah, the equator. The equator is going to be the great circle of our Earth. Spheres have radii, just like circles do. Radius is going to be distance between the center and the outside of any portion of the sphere. It's going to be equidistant in every single direction to the outside of the sphere. All right. Two equations I want you to memorize here right now. Surface area of a sphere and volume of a sphere. Surface area of a sphere looks a lot like area of a circle, pi r squared, except you're going to multiply it by 4. There are some mathematical proofs for that, why that works. We're not going to go into that here. It's about chopping up 4 different circles, and you can actually tile 4 different circles onto a sphere. We won't look at that right now, but just trust me on that. Surface area, 4 times pi r squared. Volume. Volume is kind of a unique equation. There's no good rhyme or reason for it. That's super evident right away. It's going to look a lot like, well, I take that back. Without knowing some decent calculus, there's no rhyme or reason for volume, but just roll with it here. 4 thirds, or 1 1/3 times pi r cubed. Those are going to be the 2 equations we're going to use today. If we want the surface area and volume of this sphere, for example, we know that the radius is 9, so we could say surface area is 4 times pi times 9 squared. I know 9 squared is an 81, so this is really 4 times pi times 81. All right, if we toss that into our calculators here, 4 times pi times an 81 gives us a grand total of 1,017. 1,017.88 centimeters squared because it's an area. Looking at the volume now, volume is equal to 4 thirds pi times r to the 3rd power. All right, so 9 to the 3rd power. That'd be 9 times a 9 times a 9. So plug into my calculator, 9 times a 9 times a 9, or 9 to the 3rd power, gives us 729. Multiply that by pi. Multiply that by 4, divide by 3. That's going to give us a grand total volume of 3,053.6 centimeters cubed. All right, that's our volume of this sphere right here. If a sphere has a surface area of 600 square inches and we want to find its volume, that's completely possible to do. We're going to go ahead and write the surface area equation. All right, so surface area is equal to 4 times pi times r squared. All right, that's really 600 is equal to 4 times pi times r squared. We're trying to find r squared now, so I'm going to go ahead and divide both sides by 4 pi. All right, so on your calculator here, if you divide both sides by 4 pi, 600 divided by 4 divided by pi, that should give us about a 47 point something. All right, 47 600.75. If you're getting a different answer on your calculator, check and make sure that you didn't type in 600 divided by 4 times pi. Make sure either you put these in parentheses or you do 600 divided by 4 and take that and divide it by pi. All right. At this point, we can go ahead and square root both sides. Square root both sides here. Square rooting that number, we end up getting a radius of 6.90988, and it keeps on going for a while. Excellent. We want the volume of this thing now. Volume, remember, is 4/3 pi times a radius cubed. I'm going to take our radius that we found, plug it in right there. So plugging that into my calculator, take our number to the 3rd power, multiply that by pi, multiply that by 4 divided by 3. That gives us a grand total for the volume of 1,381.98 or so inches cubed. Inches cubed for that one. For this last problem, suppose you have an ice cream cone and you want to figure out what kind of volume of ice cream you're actually eating. Well, you have a half of a sphere, it looks like. You can calculate the area or the volume of the sphere and then do half of that. You also have the cone portion, which we talked about last class. So let's go and find the area, this volume of this ice cream cone, the amount of ice cream that we're actually eating. We're going to start with volume of sphere. All right. That's 4/3 pi times our radius squared, pi times 7 squared, gives us a grand total of, plugging that into the calculator, you're probably beating me in this regard, 4/3 times pi times 7 squared is a 49, gives us 205.25. All right, so that's the volume of the sphere. Volume of a cone now. I noticed that we have a 7-something-25 triangle. This is actually a 24, 7-24-25. And that's just because 7 squared plus x squared is equal to 25 squared. If you solve this Pythagorean theorem down, you're going to get an x is equal to a 24. All right, solve it down. We won't take time to do that now, but you're going to get an x equals 24. You can go ahead and do the volume equation for a cone. Remember that volume equation is the base area times the height divided by 3. So pi times 7 squared times 24. Divide that by a 3. We can plug that all into our calculators. Pi times 7 squared is 49. So pi times 49 times 24 divided by a 3 is going to give us a grand total of 1,231.5. In other words, most of your ice cream is in your cone. Don't fret if you don't get that much of a ice cream amount on the top of your cone, but be sure to insist that they put a bunch of ice cream into your cone at the ice cream parlor. Everyone this day and age goes to the ice cream parlor after school. If we want to find the total volume, the volume total, notice that we only have half a sphere. We have a hemisphere. So we need to take our 205.25 and divide that by 2. And then we'll tack on the amount of ice cream in the cone. If we plug that all in together, so adding on 205.25 divided by a 2 to everything else, we get a grand total of 1,334.13. What you